Hello and welcome to this OXID Academy training. In this video, we will create an OXID eShop component, which is one of the extension types for the OXID eShop. We start by creating the needed files, implement an example method, register a service since components work together with services, and then install and test the final extension. Usually, everything you introduce to the OXID eShop should be encapsulated in an extension. To affect the functionality and logical processes of the shop, you can choose between component and module. A component is perfect for global and reusable functionality. A component is a simple composer package using the Symfony DI container, which registers the implemented services in the container during installation. After successful installation, the services can be retrieved in other services by using autowiring, or with the container factory. You may know if you used the query builder before. Autowiring is always the preferred way, but is only available as long as we are in a service already. At first, we must create our directory structure. While in development phase, we can start building our extensions in a directory besides our shop file structure. You can use every name you want, but we suggest to use a meaningful and noticeable directory name like extensions. Inside this directory, we place all our extensions in separate directories. We will build a service that takes an item number and returns some product data. We implemented such function before in our basic tutorials and will now move this function to our service. Therefore, our component is named Product Data Reader. This results in the directory extensions /product data reader on the same layer as source and vendor. In this directory, we place our composer.json file as well as a directory where we put all our code. You may name this directory as you want, but it's recommended to stick to the OXID's coding standards, which will be the directory src. Our composer.json file must be filled with all necessary data, which is a name, description, specific type, and autoload section, but we also recommend to add other information like author, license, and such details. The name is a combination of vendor and package name. As vendor, we use OXID training. The package is the product data reader. Therefore, we use the name OXID training /product data reader. The type is OXID specific and must be set to OXID eShop component so that the shop knows how to handle this package on installation. The autoload section follows the PSR4 standard. You define a namespace and point it to the created src directory. The namespace is up to you, but we suggest to use simply vendor and extension name again. This is the most common pick, and so in our example, it's OXID training /product data reader /. We now move our created function readData by item number to the component. To do so, simply create a new PHP class in your src directory. Since it will be a service, we may name it DataReaderService. Then add your namespace to the top of the class, move your readData by item number function to the class, and define it as a public method. Last but not least, we need to create one more file called services.yaml. This file is a configuration file to tell the Symfony DI container about our service. The file is placed in our package's root directory directly besides the composer.json file. The file's content always starts with the services key. Inside this block, we can register as many services as we want. To do so, we must provide a unique identifier. It is highly recommended to use the namespace here. The namespace is unique, and the Symfony framework can identify a namespace as service identifier to directly connect it to the corresponding class. The autowire key is set to true since we want to use autowiring in our service later on. The public key is also set to true, which provides us with the possibility to retrieve our service directly from the container factory. Otherwise, we could only autowire our service, but won't be able to use it in non-service classes or simple PHP files. It is good practice to actively set the desired configuration in our own services.yaml file. This ensures the correct configuration even if the OXID development team may change the defaults in the future. If we decide to build an interface for our service, which is actually a good practice, we will use the interface namespace as our service identifier. Symfony also identifies this, but needs a class which implements this interface. To provide this information to the framework, you need to add the class key as well. However, for the simplicity in this training session, we will not implement an additional interface, but instead use the actual class as identifier as shown here. The extension is now fully prepared. It's time to install it in our OXID eShop. To install extensions, Composer is used. Usually you will commit your package to a remote repository like GitHub or GitLab, and if it can be publicly available, you should synchronize it to Packagist, which is Composer's main repository. A remote repository would force us to first commit all our changes to the repository and then update the extension before seeing any result of the modifications. This is a huge overhead in developing phase, especially if you're a beginner and do small changes step by step. To make it easier for our training session, we will use a local repository. To register a repository in our project, we use the composer config command in our shop's root directory where the source, var, and vendor directories are located, as well as the project's main composer.json file. To define a local repository, we simply use the type path and configure our existing directory extensions /product data reader as target path. The repositories section is what needs to be updated. The OXID or -PDR is an identifier for the repository. You should use a unique identifier here, like your vendor and package name or corresponding abbreviation. The command does not return any output on the console, but you can verify its execution in the project's main composer.json file. The repositories section should be extended with your local repository. Composer can find your package now, and therefore we are nearly ready to install it. If we would try to install the extension now, we will receive an error message since our package is not available in a stable version. The stable version is needed due to the minimum stability that is set per default in a clean OXID eShop installation. Therefore, we change the stability simply to dev. Now we can use the composer require command with our package name to install the extension. The composer require command will search for the package in our configured repositories, should find the product data reader if we set up everything correctly, and copy it to the vendor directory. Since we are using a local repository, the contents are usually symlinked to the vendor directory. If not, you should set up the symlink yourself to ensure you can code in extensions directory, but all changes are also directly represented in the shop's vendor directory, which is the location the shop loads the extension from. This is the ideal situation to develop our extension without all that overhead of committing and installing again and again after each change. The composer execution registers the namespace and also triggers the OXID eShop composer plugin, which recognizes the package as an OXID eShop component due to the set type and registers all services in the service container that are defined in the services.yaml file. You should see an output telling you your component is updating. Since it is an OXID eShop component, after installation the service is globally available with autowiring or via the container factory. Now it's time to test our extension and optimize it a little bit more. To do a small test, we will use a simple PHP file. In extensions, you should add a new file, test.php. We need to use the container factory to retrieve our newly introduced data reader service. Also, do not forget to include the bootstrap.php to initialize the OXID framework as well as the necessary namespaces. After retrieving the service from the container, we can call the readDataByItemNumber method and output the return value with var dump. Now you can call it via CLI. This should result in an output of the product details on the command line. If you encounter any issues, you should clear your shop's cache source/tmp, and if you still have some errors, check the oxideshop.log. If everything is fine, we want to enhance our service a little bit more. Till now we only used the container factory to get our services. As mentioned before, this is needed in non-service classes and standard PHP files. However, obviously our readDataByItemNumber is a method of our data reader service and not just a simple function in any PHP file. This gives us the possibility to use autowiring, and if we are able to do so, we should do it. Currently, we call the query builder factory via the container factory. This will be removed and we autowire the factory instead. Autowiring is actually super simple and just a combination of dependency injection and type hints. All we have to do is to inject the Query Builder Factory interface in the newly added constructor of our data reader service class. In this example, we use constructor property promotion, which means we provide visibility, type, and variable name all within the constructor's arguments. This way it's just one line of code and we have the Query Builder Factory instance auto-wired and set to a private class property to call via the keyword $this. Also pay attention to the type hint. In this case, the OXID framework uses an interface for the service to provide this extra abstraction layer like described before. The framework does this in most locations. We need to use the services identifier, which is the interface namespace and not the class, which implements this interface. However, what we receive is the service itself, which is per configuration the actual class. After this little modification, you probably need to clear the shop's cache again. Then the new service configuration is registered and the Symfony dependency injection container does the rest. No need to provide the Query Builder Factory service as an argument when we get the data reader service from the container. The injection chain is resolved by the framework. The Query Builder Factory may also autowire some more services. For more information and tutorials about the OXID eShop, check out our other videos or head to the online documentation.